Thank you. Good morning, everyone. Welcome to Bloomberg. Our discussion today is around AI infrastructure and software architecture. On the extreme left is Peter Solanki. He's the co-founder and chief technology officer of CoreWeave. Peter oversees CoreWeave's technology strategy and the development of its AI cloud platform, including infrastructure, software, architecture, engineering, and allows customers to deploy one of the biggest neoclouds, or the biggest neocloud now in the market. Umesh Sachdev, he's the CEO and co-founder of Uniphore. It's a sovereign business AI platform focused on helping organizations turn AI into real business. You have more than 2,500 enterprise customers worldwide, approaching 1 billion in bookings, and growing over 100%. So let me define by the first common question for both of you. How is artificial intelligence changing the core part of what the two areas that you focus on? That would be infrastructure for CoreWeave and the software architecture for Uniphore.
Sure. I'll go first since you looked at me. Good morning, everyone. I think it's important to differentiate how different infrastructure purpose-built for AI needs to be with a traditional hyperscaler, right? You think, and I've gotten this question ever since 2019, like what you're doing different than what Amazon are doing? And if you look at the core architecture of the traditional hyperscaler cloud stack, they're built around 20 years ago, and they're very good for their purpose, which is running many parallel applications that all need to be kind of contained in a box, and you might have many of them, but they're not actually interconnected to each other. This is something like running a bank website where, it needs to be 100% of the time that you go in and you put in a stock trade, it needs to be there. But they're not optimized for workloads that need to talk to each other, or workloads that have massive scale, where performance might actually matter more than utmost reliability. So when we look at, especially on training, but also on inference, these large clusters of compute that work together on one job, right? It's not a bunch of individual kind of tasks that work on, they work together on one thing. Then the traditional hyperscale architectures are built around, we take half the bandwidth, kind of throw it away for redundancy. It's better to kind of give up half of our infrastructure for redundancy than risk having any failure. If I go to one of my customers and say, hey, I'm going to take half of this $10 billion data center, and I'm going to keep it on the side for redundancy, but your job will never crash, they will kind of tell me to, jump out the window or something, to use not too strong language. And that requires, and since no one wants to waste the compute is now so valuable, you need to build an architecture where you can push everything to the max and expect that something will sometimes fail and handle it gracefully. And the traditional hyperscaler stacks are so built around making sure that failure never happens at any cost that they end up being a really, really bad fit for these kind of high power, where every single dollar, every single flop matters use cases.
So I'll build on top of what Peter said. Look, in the space of infrastructure software, much like what Peter said, the paradigm is different. Unlike in the past, we're not selling software to the enterprise, we're selling intelligence. And what that means is the role of, therefore, infrastructure software is now more orchestration than productivity. And what does that mean? The first challenge that an enterprise has to deliver value through agentic AI is, how does a model or agentic AI understand the enterprise's data, as was being spoken in the previous session? So software layer has to come in and convert data into knowledge. It's called ontology. Some people do it through human curation, like FDE model. People are now beginning to use data agents. The second task that this software has to do is context, which is probably the hardest part of an enterprise. What is context? Context could mean a person called Joe who's worked in IT support for 15 years and has all the tribal knowledge of how IT support works in this company, or Samantha who's been in customer support for 30 years. That tribal knowledge, that context, how work is done in the enterprise, unless an agent understands that, the agent can't do a great job at mimicking that work in the AI era. So extracting context is the second part of software. Once we've done these two things, now software needs to harness it around a model, a large model, a small model, and take this knowledge and context into the model, so the model starts to understand how one enterprise works versus the other enterprise. And finally, AI agents now or agentic workflows can be built on top of this LLM, which has learned how the enterprise works, and the agents start to work in the enterprise. So think about this new paradigm of infrastructure software as a 4-tier architecture: data, knowledge, models, agents. And now you need to put together all of this in a governed, secure, open architecture. So that's the first big difference from software from the past. The second key difference is that in the SaaS era, we were all taught focus is a great thing. Vertical SaaS is the winner. For sales, you go to Salesforce. For service ticket management, you go to ServiceNow. For HR, you go to Workday. In AI, because it's an architecture shift, it goes from being vertical to horizontal. And there's a reason why the commentary around SaaSpocalypse or other things are happening, because the paradigm has completely shifted. And in the AI era, it's no longer selling software. The role of software is to deliver intelligence.
That's fair. So, Peter, when we think about the biggest topic that we hear about from investors is the cost of tokens. And that is the single biggest topic for us of discussion right now. What do you do on the infrastructure layer to make sure you are delivering the cheapest tokens possible without sacrificing the performance or the speed?
Yeah, and token cost, I mean, it's a very easy to reason around number, right? An easy marquee number to focus on. But when you start breaking down what that actually means, it's not just having the latest and greatest hardware or finding the cheapest power. That is definitely a component of it, but there's so much other things in the infrastructure that matters. It is how can we have a diverse set of compute so we can create an ensemble of compute for our customers that allows them to deliver both a product that is fast, because no one wants to sit and wait for their ChatGPT or their Claude to make their PowerPoints. I'm sure you all have been frustrated with that. And do that while still being cost efficient, right? And it's around how are you responding to market movements. When we started out, right, building a GPU cloud in terms of capacity planning was easy. You put in as many A100s as you could in a data center, and then you sold it. Now, things are changing. We have RL, we have agentic use cases. So now you need to have a mix of CPU compute. You need to figure out how do you scale and what type of storage you have for KV caching. So there's so much more in how the shape of the infrastructure looks like to be able to deliver a product that is both fast, reliable, and has the most efficient cost. So it's not just, take the latest Vera Rubin and plug in as many as you can of that. To be clear, we do a lot of that as well. But there really is so much more parts of the infrastructure now that go into actually running these models and agents in a both performant and cost-efficient fashion.
Fair. And Umesh, the same kind of question for you, because one of the arguments we have made that eventually down the road, there could be some distilled model or smaller models that can change the shape of inference. Is, what's your experience? How are you telling clients what they can do on the software side of it to reduce these cost of tokens?
So about 3 years ago, Uniphore made a series of consequential choices around this very topic. First of all, around the room, if I were to tell any one of you that I have the ability to deliver you the same intelligence, or about 98% of the intelligence of a frontier LLM today, I can meet 98% of that with 93% less cost. Interested, anybody? Those are now open weights small language models. The difference between a Claude Sonnet, Anthropic's latest generation, or Gemini's latest generation frontier model, versus a Kimi and Orca, which is OpenAI's open weights model, or Gemma, which is Google's open weights models, the difference in intelligence is very narrow, but the difference in cost of token is now very wide. So what Uniphore did as a choice number one, was to create a harness around open weights small language models, which we deliver in a tech stack to the enterprise that doesn't require an army of data scientists. Because one of the arguments against these open weights models is, who will fine tune them? Who will train them on the enterprise? LLMs have this context window. It's easier to work with. So we've solved that problem by saying, look, we can automate the fine-tuning of these small models and deliver, first of all, 93% reduction in token cost. The second consequential decision we made is on the agentic layer. We understand that agents have to reason. I liken it to my teenage daughter. I tell her, we have to do this every Monday. We go to school. She says, I understand we go to school. Why do I have to? Teenagers reason, AI agents reason. They want to find different answers to the same problem, the most optimal answers to the same problem. The issue with this is when you work with a regulated industry, say banking or healthcare, you want a deterministic outcome. And so the way to solve that is neuro-symbolic. Neuro-symbolic. What does it mean? That part of the agent workflow will reason. It will go to the SLM or LLM to say, what should I do? But part of the agent workflow will just look at code and just follow code. No reasoning for these 4 steps, just follow code. What that does for token cost, though, is for a vast majority of the agent run, it's not even hitting inferencing. It's not even hitting the intelligence because it was done once and now it just follows the sequence. So that was consequential choice 2. Our third, and probably the most important choice, was around inferencing. Peter touched upon this. Inferencing, think of this as a software layer running on top of GPUs. On top of NVIDIA's CUDA, you do a bunch of things. On top of AMD's Tensor, you do a bunch of things. And there's ways to optimize that software, because you don't need all of that to run all the time. So for different types of workflows, you need some type of software. For others, you need others. But in the Uniphore platform, we had one superpower that we said that it's worth like harnessing that, which is at any given point of time, because all of our 2,500 customers' workflows, agentic workflows run on us, we know what the agent wants to do right now. If it's a voice AI agent, 500 millisecond latency is too big. We need quick response, so latency has to be optimized. But if it's an agent running for my CFO, the response can be 5 minutes later. The CFO could wait, but the CFO wants precision. If you knew this at every millisecond for every agent, you will optimize inferencing at real time. We call it context-aware inference optimization. So a combination of going SLMs, small language model versus large language model, going neuro-symbolic on the agents, going context-aware inferencing, we are able to extract 100 to 200x lower token cost. And I'll wrap this up with one 60-second example. We work with a very large European bank which agentified their entire compliance AML. And last year on Frontier OpenAI on Azure, they spent $34 million US annually for compliance agentification, wall to wall. We stuck to Azure because that was their choice. We moved them to an open weights SLM, which was still coming from OpenAI. It's called OSS. And that 34 million annual spend with similar or higher accuracy this year has gone on to 4 million annual spend. So tremendous amount of optimization available in the architecture, software. Like I said, the role of software is shifting to delivering intelligence and delivering it effectively.
Fair point. Peter, when we look at the chip discussion right now, and again, going back to the lower cost per of token, you've been one of the first neo cloud providers to get the latest NVIDIA chips, the latest rack. What has been your experience in terms of deploying that in both in order of performance as well as cost?
Yeah, so I mean, we were first in the world to bring H100 to the market. We were first in the world to bring Grace Blackwell to the market. And we're first in the world to bring Vera Rubin as a fully validated rack, and now we're working on multi-rack setups. Pretty excited about Vera Rubin. We were pretty excited about Grace Blackwell as well. I think it will do great things into speeding up all of our AI tools. And there's a lot of new innovation there, right? And the platform seems pretty solid. There's a lot more going to it. Kind of back to my previous answer. Like, I don't want people to be myopic on, Vera Rubin is what's going to change everything. It's again how you build Ensemble, how we get into CPU running for the agentic use cases, and how you utilize software better. So is the platform looking like it's going to live up to Jensen's claims? Yes, based on our data and our initial tests, and we're hoping to publish something publicly here in the next couple of weeks. It does, but there's a lot more to it, and you really need to have optimizations all across the stack, not just focus on I need the latest and greatest NVIDIA chip, and that will solve all my problems. To truly be able to harness all the power and your compute efficiency that you have.
So should I expect you to always stick around the NVIDIA family, or you can pick other chips down the road as well?
Our stack and our company is built agnostic, right? We don't build our stack on top of necessarily NVIDIA technology. We use a lot of NVIDIA technologies in our stack, and we obviously have a lot of NVIDIA expertise and deep partnership. So the primary reason that we are doing pretty much exclusive NVIDIA is because we're customer-led, right? There's a lot of hype right now around chips, Neo chips, but if you actually ask customers, if you look at what are people actually running on, it's NVIDIA. Like, that's where we see the demand, and we don't really see that changing. I think there's a lot of hype. I think a lot of the hype is driven by kind of a desperation to, like, I need to find something that is the next NVIDIA, more so than actual usage and actual deployments in data centers. So if the markets were to change, we might were to change, but like, market is asking for NVIDIA, everything we see forward is NVIDIA, and they are producing the best results. And for us as a company, we have so much demand, we always have more demand than we can fill. It wouldn't make sense for us to shift our focus or split our focus, right? These things are so hard. Like the new generation, right? The reason we're first is not because, like, Jensen sends us the GPUs first, he sends them to everyone at the same time, but we have such deep expertise into running and have built such a stack around it that we can get them up and running and working before everyone else. And I don't want to dilute that by focusing on another chip with very little demand. I'll keep my focus on what our customer wants, and I'll be the true expert on kind of one thing versus being good at multiple things.
That's fair point. Umesh, we heard a lot talk about models and the potential commoditization of that. What's your view on this topic, especially as so many of these frontier models are coming up with new performances every day? What do you think is the real value for an enterprise, not so much for a consumer use case, but for a bank or a retailer, whether it's the model or is something else?
So, look, half the people I meet believe that some form of AGI has been achieved, and half the people I meet believe that it's about to be achieved. So the net outcome of that discussion is there is already enough intelligence available. When I think about purely enterprise use cases, my customers, is very different from the requirements of consumer AI. There is already some form of super intelligence available to the enterprise. So the question is, why is it that every enterprise on planet Earth has not already gone autonomous and agentic and AI running everywhere? The friction point is less about the model, and the models will keep getting better, and we have to expect that. It's more about how do you orchestrate data, context, models, and agents in a way that companies and regulators and consumers can build trust and extract real business value. So it's more the value capture, which still largely is in the picks and shovels area, and it's moving up to the models layer. Ultimately, like every technological revolution, has to move to the orchestration layer. The orchestration layer, just in the enterprise AI domain, looks different, but the concept is the same. How do you take the value, the tokens coming from the picks and shovels, into the models, whether large or open weight small, and then how do you take those tokens in a form that an enterprise can conduct business on it? So let's take an example. Uniphore works with one of the top big 4 consulting firms. And in the past, the relationship with GSIs, system integrators, and consulting firms with software vendors like Uniphore was that of a reseller. That these system integrators would tell a software company that, hey, I'll buy your licenses in bulk, I'll wrap some services, I'll make margin, give me your licenses at a discount. That conversation is very different. The big 4 consulting firm is saying, how do I tokenize my expertise? My customers pay me a premium for expertise, audit, financial expertise, oil and gas industrial expertise, what have you. The form of this expertise up until yesterday was largely what's in the minds of your people. The partners of this firm have experience, the associates of this firm have experience. That knowledge can now be tokenized in small language models. Oil and gas contract use case, one small language model, fine-tuned by this big 4's experts. So now the knowledge has tokenized in the form of these models. The big 4 is now going to clients and saying, look, I can optimize your contract leakage, but instead of sending 1,400 people, because you have 160 million contracts, let's not worry about how many people I stuff. I have this small language model and agents. Of course, there'll be some people, some advisors, but we can do business now on an outcome model. The reality is one such project has gone from 1,400 people to 4 people for this Big Four. But when I say this story, most people, most journalists, most analysts think, oh, this is about job loss. To the contrary, the 1,400 people project was never approved by the CFO because it was too expensive for the outcome that was being promised. So this kind of work could never be done before agentic AI. So the tokenization of expertise in large or small models and how you do that through an orchestration layer is the real impact, as opposed to when is the next frontier from Anthropic or Gemini due.
Got it. Great. Peter, we're almost running out of time. Last quick one for you. What's the big bottleneck right now? Power, memory, or something else?
I feel like there are bottlenecks everywhere, to be honest, right? We've been focusing a lot this year on talking about memory bottlenecks. That is definitely still the case. Kind of supplying both DRAM and NAND is tough. Power, I think power is kind of an overblown bottleneck, and I think it has been ever since people started talking about it. There's plenty of power in the world. There's plenty of power in the US. The bottleneck there is really getting it from like the transmission lines into something that looks like a data center that actually works, right? And what that contains of is transformers, HVAC, and in many cases, the professional services, which I think is, we talk about too little in the context of this, right? The power itself gets a lot of attention, but the fact that how many electricians you need and how many control system specialists you need to build these huge, football field-sized data centers, that is tricky. And having people who can do it quality, and everyone thinks that they're like, oh, I got this services firm, but I also signed up like 15 other deals on top. Like managing that is hard, and it's also a harder resource to achieve, right? Like it's easy to scale up manufacturing transformers, scaling up licensed, experienced electrician, much harder. That takes time.
Great. Umesh, Peter, thank you so much. Such a fun discussion.
Thank you for having us.